How can we stop an asteroid from hitting the Earth? Well, when I was young, I would play the video game Asteroids, and we would literally blow them into space dust with my little vector spacecraft. But in real life, asteroids are a little more robust than that. And it turns out that it's much better to try and change the course of an asteroid than to destroy it entirely. Because if you think about it, if you blow something up, the debris will keep going along that same orbit, and eventually some of it could in fact hit the Earth. And there's at least three main candidates for this. So the first idea, one that's actually going to get tested, is the kinetic impactor. That's going to happen on the double asteroid redirect test. And this basically uses Newton's laws of motion, the conservation of momentum. We take one object, like a spacecraft moving very quickly, and slam it into the asteroid at very high speed. And what that does is it very slightly changes the orbit of the object. In the case of something like the double asteroid redirect test, where we're hitting a small moon called Diddy Moon, the change is going to be measured in millimeters per second, but that's enough over time to change the orbit by thousands of kilometers over time. Now, the great thing about this is it's technology that we understand. We know how to navigate spacecraft. We know how to target these things. And so we know how to make this collision happen. The question is, how will the asteroid react? Will the asteroid get disrupted in some way? Well, that may be a problem, or it might be that the spacecraft just doesn't move fast enough. So let's take a look at other alternatives. If you want to be more gentle, you might want to, say, apply a small force to it over time. And you might think maybe we could mount a rocket engine on the asteroid and have it push the asteroid over time. Now, that's actually something we see in a video game called Mass Effect, where they have an asteroid with rocket engines on it being used to change its orbit. But in real life, it's actually much easier to not have to touch the asteroid because asteroids rotate. And if you're going to have to figure out how to land on an asteroid and lock onto it and apply that force, that's adding complexity that you don't need. Because when you have a spacecraft floating near an asteroid, it's going to feel the force of gravity on that asteroid. But Newton, again, Newton's laws said the asteroid is also feeling a very slight force from that space probe. And so you can use this gravity effect to pull the asteroid very slowly, and this is called the gravity tractor. It's beautiful. You have a spacecraft, and it orbits in this halo orbit out here, applying its engines and very slowly pulling the asteroid off. It takes a long time, but it's totally gentle. You don't need to touch the asteroid, and you don't need to develop the technology to lock into it. But on the other end of the scale, if you have something bigger, something that a conventional impact can't change the orbit of, well, some people have suggested nuclear explosions, because nuclear explosions, well, nuclear bombs basically put a lot of energy into a very, very small and light package. And mass and size are very heavy constraints when you're flying a spacecraft, billions of miles in space. So with a nuclear bomb, sure, you could actually blow an asteroid up completely, like in the movie Armageddon, or you could change its course, like in Deep Impact. But equally, you might not want to actually land a bomb on the surface. You might just want to move a weapon very close to the surface and then detonate it. And then what happens is one side gets bathed in intense, nuclear fireball heat. And as that happens, it boils off the surface, and that shoots off into space and pushes the asteroid in the other direction. So that's an asteroid deflection via a nuclear explosion. Again, that one is a little more energetic. And so if your asteroid doesn't have enough self-gravity, then it could perhaps disrupt the asteroid too much and then break it up. So there's many different possibilities. If you ask scientists for ways to deflect asteroids, they will have many other ideas. Another idea that's very simple in concept is if it's rotating, you might just paint it and change its color, and the reflectivity, the emissivity of thermal radiation, that will slowly change its orbit over time. You could use solar cells, you can use mass accelerators, mass drivers, which take debris and throw it off into space. The thing about asteroid deflection is It's not that we lack ideas, it's that we don't know which is the right one, and we may not know which is the perfect one for a specific asteroid until the scenario is thrust upon us.